So we're going to talk about function notation basics today, and what we're going to do is we're going to solve some of these problems. So these are in function notation. Now, normally when we talk about function notation, I want black, just a second, we just change this f of x to y and then start solving. The issue is you get something that looks like this. And so what we're going to do is we're going to stop doing that. We're going to keep everything in function notation. Now what this means here, this right here, it means that x equals -3. That's what that means. It means they took function f and then substituted in 3. Let me say plugged in. I like the word plugged in. That's what that means. So here we have function f. So here it is. Here's function f. And then we're going to plug in 3. Okay, do you see how I did that? Now, what's really important is this right here does not change. This is a placeholder. We don't do anything with it. Okay? We don't do anything with it. It's just going to come down and come down and come down and be part of our answer. That is it. So we're just going to stay on the right side only. So -3 squared is 9, because we're doing PEMDAS, plus 6 times -3. 6 times -3 is -18. We get -9. Now this highlight thing is going to come all the way down and be part of the answer. And I'll talk about why that is later. But that is our answer. On question 2, we're given two functions now. We have f of x and g of x. And then we're asked to find these and then add them. So what we're going to do is we're going to do this twice. We're going to solve twice for each equation and then add. So let's do that. So we have f of -2 equals f times -2 plus 1. Again, we have a placeholder there, so I do nothing with it. So I have f of -2 equals -9. Ironic that we got the same number. Not always the same. Now g of -1 is what I'm going to do next, and that's going to be -2 times -1 plus 5. So this means, so g of -1 means that I'm going to find g and put -1 in for each x. So I did. Again, and I'm going to highlight these. These don't change. They're just placeholders, and we're going to write them as part of the answer. So a negative times a negative is a positive. So we get 8, and then we write down that. Now notice what we have here. I'm going to highlight all of these. Okay? So we're going to substitute it in. So g, or f of -2 is -9, so I'm going to have -9 plus 8. So I get -1 for the answer. So what do we do here? I took -2 in f, and I put it in for f. Then I took -1 and put it in for g, because that's what it tells me with those letters. And then the answers to those I'm going to add together. So this one's a little interesting. To help make sense of what's going on here, I'm going to cross this out and say y equals 15. Now g of x is all the way up here. G of x, so I'm going to write it out. G of x is -2x plus 5. So I'm going to cross out g of x and write y instead. And then now this should make sense. This should make sense, because we're just going to put a 15 in for y. So notice how this looks. So let's go back here. I'm going to highlight in green, because notice how this looks. When it looks like this, it's different compared to the purple highlights. Do you see the green highlight and the purple highlight? Completely different. The purple one we're putting in for x. The green one we're changing it to y and putting in for y. And then we solve. Alright, so we're going to -5, 10 is equal to -2x, divide off -2, get x equals -5. Okay? Alright, that's it, that's how we solved it. So notice the difference between the green and the purple. Now we have this. I'm going to highlight in purple because this looks just like what we did up here. at the first equation right here. I'm gonna purple this too. So they look the same. Does everyone see that? Negative 3, 9, 3, 10. So it's a different function, but it's the same. And the reason why we write it like this is because this is actually a coordinate point. This is 3, 10, x, y. And it goes on a coordinate system, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right here, 3, 10. And so we write it in this manner so we can keep track of everything that we're using and putting in and putting out, so we can actually visualize our answers on a graph space. It's kind of neat with function notation because when we have y equals, it doesn't do that. Hopefully this makes sense. If you have more questions, let me know. We do have that worksheet that's going to be posted. Have a great day.